In this video you will learn about the test of hypotheses for nominal data.
Example 1. Students who are homeschooled often attend their local schools to participate in various types of activities such as sports or musical ensembles. According to the government, 82% of homeschoolers receive their education entirely at home, while 12% attend school up to 9 hours per week and 6% spend 9 to 25 hours per week at school. A survey of 85 students who are homeschooled revealed the following information about where they receive their education. Entirely at home. The frequency is 50. Up to 9 hours. The frequency is 25. 9 to 25 hours. The frequency is 10. At 5% significance level, is there sufficient evidence to conclude that the proportions differ from those stated by the government?
In this example the null hypothesis is percentage according to government, that is, 82% homeschoolers receive their education entirely at home. 12% attend school up to 9 hours per week. 6% spend 9 to 25 hours per week at school. The alternative hypothesis is percentages do not follow the distribution as in null hypothesis.
The test statistic under the null hypothesis is a chi-square, which is equals to sum of O minus E square divided by E. That will follow a chi-square distribution, with degree of freedom equal to the number of categories minus 1. Here, O represent the observed frequency and E represent the expected frequency. The chi-squared statistic is much easier to calculate using the following formula. Sum of observed frequency squared over the expected frequency minus the number of observations, n.
So, in example 1, we will calculate the chi-squared test statistic as follows.
The total number of observations is 85. The expected value of A is 85 multiplied by the null hypothesis percentage of 82%, which is equals to 69.7. The expected value of B is 85 multiplied by the null hypothesis percentage of 12%, which is equals to 10.2. The expected value of C is 85 multiplied by the null hypothesis percentage of 6%, which is equals to 5.1.
For A, O square divided by 69.7 is equals to 35.868. For B, O square divided by 10.2 is equals to 61.2745. For C, O square divided by 5.1 is equals to 19.6078. The total for O square over E is 116.7503.
Hence, the chi-squared test statistic is 166.7503 minus 85, which is equals to 31.7503. Under the null hypothesis, the test statistic chi-squared is 31.7503, which will follow a chi-squared distribution with 3 minus 1, which is equal to 2 degree of freedom. At alpha 0.05, the critical value is 5.991. We can reject the null hypothesis since the test statistic is inside the critical region. Conclusion: there is enough evidence to conclude that the proportions differ from those stated by the government.
Example 2. A survey at a ballpark shows this selection of snacks purchased. At 10% significance level, is the snack chosen independent of the gender of consumer?
In this example, the null hypothesis is snack chosen is independent of gender. The alternative hypothesis is snack chosen is dependent of gender.
This is called the tests of independence of two variables. The frequency table is a two-way frequency table with I row and j column.
The test statistic under the null hypothesis is A chi-squared, which is equals to the total sum of the observation ij minus expected value of ij squared divided by expected value of ij, with row minus 1 multiplied by column minus 1 degree of freedom.
To calculate, it is much easier to use this formula.
In example 2, we start by taking the marginal total of the observation for the rows and columns. For instance, the marginal total for the first row, M, is 52. The marginal total for the second row, F, is 46. The marginal total for the first column, A, is 25. The marginal total for the second column, B, is 29. The marginal total for the third column, C, is 44. The overall total is 98.
The expected value is calculated by taking the marginal total of row multiplied by marginal total of column divided by the overall total. For instance, the expected value of row 1 column 1 is 52 multiplied by 25 divided by 98, which is equal to 13.2653.
Next, the expected value of row 2 column 1 is 46 multiplied by 25 divided by 98, which is equal to 11.7347.
Next, the expected value of row 1 column 2 is 52 multiplied by 29 divided by 98, which is equal to 15.3878.
Next, the expected value of row 2 column 2 is 46 multiplied by 29 divided by 98, which is equal to 13.6122.
Next, the expected value of row 1 column 3 is 52 multiplied by 44 divided by 98, which is equal to 23.3469.
Next, the expected value of row 2 column 3 is 46 multiplied by 44 divided by 98, which is equal to 20.6531.
The sum of OIJ squared over EIJ is 104.3421. The chi-squared is 104.321 minus 98, which is equals to 6.3421.
Under the null hypothesis, the test statistic, chi-squared is 6.3421, which follows a chi-squared distribution with 2 minus 1 multiplied by 3 minus 1, which give us 2 degree of freedom. At alpha is equals to 0.1. The critical value is 4.605. The test statistic is inside the critical region. So we reject the null hypothesis. Hence we have sufficient evidence to support the claim that snack chosen is dependent on the gender of the consumer.
Thank you for watching.